look at rational expressions in the context of multiplying terms. And we have, fourth case, we have x squared minus 4 over 3x plus 9 times x plus 3 over x squared plus 2x. And if I display what I have here in factored form, so we have for x squared minus 4, okay, we have a difference of squares, and upon factoring we have the quantity of x plus 2 times that of x minus 2 for 3x plus 9. So I have 3 times, okay, the quantity of x plus 3, and I have times x plus 3. And for x squared plus 2x, greatest common factor is going to be at x. So writing in factored form, I have x times, okay, the quantity of x plus 2. And we have common factors that exist, okay, one of which we have x plus 2. And also we have x plus 3. And it turns out that, okay, so we have for both x plus 2 and x plus 3. Okay, those would just go to 1. And in terms of what we have in simplest form, okay, it turns out that for what we have in the numerator, we have only x minus 2. And as for what we have in the denominator, okay, we have 3x. So you have 3 times 1 times x times 1, so we end up at 3x. So we have for the final answer in this one, we have x minus 2 over 3x. Now, and let's say that if we take what we have and put it in the context of division. So we have, in this particular situation, so still working with rational expressions. So we have 2x squared plus 4x over 3x cubed plus 9x squared, and we have divided by, okay, we have x plus 2 over 3x squared plus 9x, and if I just rewrite this division statement in the context of multiplication, and we'll go ahead and do it before we do any factoring. Okay, so we had 2x squared plus 4x over 3x cubed plus 9x squared. And we have times, okay, and just flipping the ratio. So we have 3x squared plus 9x over x plus 2. Now, in taking what we have here in factoring, so we have for 2x squared plus 4x, now the greatest common factor is going to be at 2x. And so we have 2x times the quantity of x plus 2. And for 3x cubed plus 9x squared, the greatest common factor is going to be at 3x squared. And so we have 3x squared times the quantity of x plus 3. For 3x squared plus 9x, greatest common factor is going to be at 3x. And I have times the quantity of x plus 3. And I have all over x plus 2. And so we have, in the case of reducing, okay, so I have x plus 2 in both the numerator and denominator position. Also, I have x plus 3 in both numerator and denominator position. And technically, I can go ahead and reduce the monomials in the cross multiplying, but we'll just put that at bay. So we just go ahead and multiply together the numerators and denominators. So I have 6x squared from 2x times 3x product. Okay, so we have 3x squared, and so we have 6x squared over 3x squared. X squares cancel, and so we have 6 over 3 is going to reduce to 2. Now, in taking what we have, let's say from page 51 in your textbook, And we have a multiplication problem. So we have for 27. So we have 3a to the 5th, b to the 7th, over a minus 5b. And I have times 2a minus 10b. And we have over 12a to the 4th, b to the 10th. And if I take what I have here and put in factored form, so we have 3a to the 5th, b to the 7th. Again, we have over a minus 5b. Okay. And I have times, again, we have in factored form for the numerator. Okay, greatest common factor is 2. And I have times the quantity of a minus 5b. And we have over 12 a to the 4th, b to the 10th. And so we have in both numerator and denominator positions, okay, have a minus 5b, so we can get this binomial to go out, and we'll just multiply the numerator and denominator terms. So we have 3a to the 5th, b to the 7th times 2. So we're going to have 6a to the 5th, b to the 7th. And we have all over 12, a to the 4th, b to the 10th. Okay. All right, so we have, for this particular ratio, all right, so you have a higher degree in a in the numerator, and we have a higher degree in b in the denominator. And so just looking at what we have in the reduction. Now, for what we have in the case of taking what we have for the ratio. Okay, so we have now for 6/12, ultimately that is going to go to 1/2. Now for a to the 5th over a to the 4th, okay, so just take out the smaller degree for b to the 7th over b to the 10th, doing likewise. Okay, so we had the smaller degrees in a and b to go out, and once again 6/12 is going to go to 1/2. And so for what will be left over, so we have a to the 5 minus 4, so this will leave us with a, and we have in the denominator again, so 12 goes to 2, b to the 10 minus 7 goes to b to the 3rd. And so we have in the result, we have a over 2b cubed. Now, and what we have regarding, okay, number 28, and we have for this one, so we have 8x minus 3y over x to the 3rd, y to the 4th. We have times 6x y to the 8th. And we have over 24x minus 9y. So we have 8x minus 3y over x cubed y to the 4th. Again, we have times 6x y to the 8th. And factoring, okay, so we have 3 is the greatest common factor of 24x minus 9y. So we have 3 times the quantity of 8x minus 3y. And we have 8x minus 3y is common in both the numerator and denominator positions. So these will go out. And in taking what we have now, so we have 6x y to the 8th. And we have all over 3x to the 3rd, y to the 4th. And if we just go ahead and simplify, So we're going to have, in this case, so we have 6/3. This will go to 2 in the numerator. We have x and x cubed. Now we have 2 degrees higher in x in the denominator. So we have x squared at the bottom. And as for the numerator, we have y to the 8th over y to the 4th. In this case, we have y to the 4th. And for this final answer, we have 2 times y to the 4th over x squared.